Here's a late 70s to early 80s 5¼ inch disc drive. It had 6 discs in it. It's got a linear actuator here. This is about the size of a Campbell soup can. Moves back and forth. This is a voice coil like a speaker. You can see how big this thing is compared to a US bill. This thing is huge. It's actually a giant aluminum casting. The thing is a 1/4 inch thick. It's just monstrous. It's all honeycombed in the bottom. Looks like something out of an automatic transmission. And made in USA. And this thing is absolutely huge. I got this some scrap in the late 80s. Just wanted to document this thing. It's kind of corroded. Got some salt damage here in Katrina. Anyways, this has got a linear actuator here. The spindle is over here. It had a disc pack of around 6 discs. They made different versions of these where it had a different carriage here, which can have 4 discs, 6 discs, depending on the configuration. The heads attached onto here that go back and forth. The spindle bolts into the bottom here. There was a filter that went into this area. The power that drives the heads is through this wire, so if you clip the wire, you can feel the drag here because you're shorting out the voice coil. If you unclip the wire, it's very easy to move. So when it's shorting out the coil, you've got viscous drag. It feels like you're pulling it through a bunch of molasses. It's got little bearings down here. Runs on the rod. It's what you call a linear actuator. These were used for many, many years, from probably the late 50s, 60s, 70s into the 80s, perhaps the early 90s, and they've pretty much all gone rotary. But this is how an earlier disc drive worked as far as the actuator. Got the voice coil in here. Is just like a speaker in your earphones, earbuds, radios, car stereo. It just goes back and forth. This has got a fixed magnet inside. This is made by System Magnetics in Anaheim, who made a whole bunch of actuators in this area. On a 14-inch drive, this motor is about as big around as a dollar bill, and it's probably 1.5 times larger. It's absolutely monstrous on a 14-inch Winchester. This is just a little 5¼ inch, 5½ inch drive here. It's got the wall thickness on this is kind of crazy when you look at today's drives. This is 1/4 inch, 6 millimeters thick at least. I mean, you could put this thing on top of a car and it's not going to crush. It's so darn thick. And here's the filter that's down inside here. You can see it, the airflow. You could go in here and replace this filter if you wanted to. Had an external access for it. In this era, this little gizmo here was a beryllium copper spring with a special Teflon pad that was used to ground the rotating end of the spindle that stuck through here. And what would happen is if you didn't ground this, the spindle would get charged up because the grease basically is non-conducting. So static electricity would charge it up, and then it would zap the heads and you blow the heads up. So in that era, a lot of Winchesters generally had a discharge finger on here, which touched the edge of the rotating end of the shaft here and discharged it. And these things would either wear out or squeal. That's why this thing is made here with a removable deal, and you could replace it. They tend to squeal or they just wear out. Later on, they ended up using a seal that had ferrofluid in it that was conducting, and that would self-discharge through the ferrofluid seal that was used to prevent air from passing. But they also eliminated this thing, which was a very bad maintenance item because they tended to wear out, they tended to squeal, kind of a sore subject. Anyways, this is a 5¼ inch rotary. It's linear actuator. I'm not sure if this is a PerTech or it's a control data drive, or it might be an IMI, it might be a, there's a lot of different names from that era. I'm not really sure what the brand of this was. I'm sure I'll get corrected. Anyways, this is the plate here to get the actuator out. If I want to clean this up, you undo the snap screw, you pull this out, and this actually has a preload spring on it. So this thing defines the load on the bearings, so it takes out the play. And if it's too tight, you're going to wear the bearings out. If it's too loose, it's going to flop around in the wind. So this is a stainless steel plate. Generally had stainless bearings on here. They may not be stainless, but the plate generally is a hardened 440C stainless plate with a spring on here. And to get these bearings aligned on these shafts is kind of a critical thing. If they're not on there just right, they're going to wear out. You're going to have a lot of drag, and it's going to be to where it's hard to go through and figure out where it is. In this particular drive, there's no, I'm not sure if there was an encoder on here or not. Some of them are closed loop where you actually read the tracks with a wedge scheme to go ahead and take out the air on it. The cover, of course, goes on here with sheet metal. Picture bigger thing, the motor bolts in the back. So when you look at all this and you look at the casting, it's just totally amazing. This thing, the amount of size of this thing is just monstrous. Like they just, from an era where they were designing something out of a locomotive, but that's how the early drive industry was. I still have this thing because I've used it for, sometimes from vibration testing. You can bolt something on here, move it back and forth with the power amplifier like on the stereo. This will move back and forth real well with the 20 watt or 60 watt power amp. This thing will move back and forth. Just in case you want to do some vibration testing, you put something on here, you can shake the heck out of it. Put an accelerometer. But anyways, this is a 5.5 inch, 5.25 inch Winchester drive from probably the mid 70s to early 80s. This particular one looks like it had 6 different discs on it. I've got the spindle around here somewhere, but that's all been separated. It's got a huge die casting. This thing weighs probably 15 pounds just for the actuator. I think this was around probably 10, 20, 30 megabytes. I'd have to do some more research to see what the capacity was, but it wasn't much for that era. Some of them you had only about 10 or 15, 10 megabytes per disc per surface. And the coercivity of the discs at that time was around 300 Oersted, pretty low. And the track spacing was pretty low. It may only be like 300, 600 tracks per inch.